In order to get a better understanding of this formula here, let's first take a look at an example. So in that example, we will have a particular form, functional form for that bond price. And then because we know the particular functional form, we can then have the first and the second derivatives and then make an actual adjustment. Now, in this example, let's look at a contract that pays a cash flow at time t equals to notional and the RT times this tau here, where RT is the interest rate between the big T and T star. So tau is really this time difference here. And so RT is, in this case, is the yield, in this particular example, is the yield at time t of a zero coupon bond, G. Okay, so now we have a functional form that links the price of the zero coupon bond with its yield. Okay, so now why not in the notation earlier here is really if we know the floor price of this zero coupon bond, why not is the implied yield here? Okay, so we can make a substitution if F naught is what we call the forward price of G based on a implied yield of Y naught, then and it's of this particular form, we have Y naught, we call Y naught as the forward yield. Now, now if R, the big R 0 or R naught, be the forward rate at time 0 for the period here. Now, by definition, because we call this the forward yield, so if R naught is the forward rate, then they're the same, right? By definition. Then we will have to then adjust this R naught. So the reason I use an R naught here is just to be consistent with this initial setup here, because we use RT here. So RT is the realized rate, and R naught is really the implied rate at time 0. Not expected rate, the implied rate. The expected rate is one we try to obtain after the adjustment. So from the floor price of zero coupon bond, we're able to obtain this R naught. And then, because we know the functional form, we can calculate the first and the second derivative here. Then we can plug in that particular formula. So we will then have an adjusted value then for us to use. Now, later on, we're going to show that this implied yield is actually the expected realized yield, but the expectation is based on a different numeraire. Because if we look at it earlier, we're saying we need RT YT. So this expectation here is taken for a zero coupon bond that matures at big T. Whereas we show that this thing here, this expectation is taken with a zero coupon bond that matured at T star. So this to a, it is an expectation, but it's an expectation of a with a different numeraire. i.e. under a different probability distribution or under a different equivalent martingale world. Okay, let's take a look at the actual calculation here. So we have this functional form. So you take your first partial derivative, you have this. Your second partial derivative, you have that. And you just plug in that those expressions here. So with some manipulation, you will get a form here, okay? So we'll again see this form when we do timing adjustment. So that shows some sort of a consistency or equivalence between the two type of adjustments. So now you have this form. So this form is a specialized form for zero coupon bond. If zero coupon bond, the yield of a zero coupon bond is the reference rate, then this is the formula you can use directly, and which is out of this generic form here. Okay. So you can actually see this excitation is this thing and an adjustment, which this thing is also an excitation, but with a different numerator. Okay, let's see an actual numerical example. So for contract that pays in 3 years, an amount equal to the 1 year risk-free rate multiplied by 1,000. Now suppose the current forward 1 year risk-free zero rate 3 years out is 10% per year with a volatility of 20%, means that the current forward price of zero coupon bond has an implied rate of 10%, okay? And that rate has a 20% volatility. The 3-year discount factor is 0.7513. And so let's calculate what's the value of this. So in this case, your current implied yield is 10%, volatility 20%, time to maturity 3 years. It's a 1 year rate, so tau is 1. And the zero coupon bond here has a value of 0.7513. So you put in this numerical number into this particular form, you will find that that particular contract is going to cost you $75.95.